Hi everybody, my name is Aaron Kessler. I am the Assistant Director for Learning Sciences and Teaching at MIT Open Learning, part of the residential group. Shout out to Cheryl Barnes, who is in the room, and our director, so it's nice to see Cheryl here. Thanks for joining us. Thanks to everybody who's here. Thanks to everybody who's joining on the video. I'll be joined today in my talk by my colleague Lauren Totino, and a huge shout out to Jovi Nazareno, who is the one responsible for actually making sure all of these events happen and function the way that they should. So thank you, Jovi, for all of your hard work. Great job. All right, so let's jump into it. So today's talk is using learning engineering to improve instruction at MIT. And really the goal for the talk, from my perspective, and I think Lauren's as well, is to sort of introduce this idea of learning engineering, the learning engineering process, and give some examples of how it's being actualized across MIT. These are going to be some high-level examples. We're not going to get into a ton of details about each one of them, but we are going to try to sort of give you an overview, and happy to talk about these examples one-on-one, maybe later. So let's talk a little bit about learning engineering and the learning engineering process. Recently, along with a number of other colleagues, was proud to put out the learning engineering process diagram, just part of a chapter in the learning engineering toolkit. So I just want to put that up there for a minute, let you take a second to look at that, digest it, and then we'll talk about a definition for learning engineering. So what is learning engineering? Learning engineering is a process and a practice that applies the learning sciences using human-centered engineering design methodologies and data-informed decision-making. And this is all done to support learners and their development. So that's the definition of learning engineering from IEEE and from the book. And what we try to do in the learning engineering process is we try to talk about what it means to actually do that work. So to take this idea of learning engineering as a definition, turn it into a process that actually allows us to support these learners using these practices. So let's talk about what this looks like. Let's talk about this centerpiece, the challenge. Because that's where we always start. We start with that central challenge. What is it, right? We start with a piece where we look at a problem associated with learners or learning, right? And it needs to be really goal-oriented. We need to be thinking about, like, what is it that we have that we want to achieve with our learners? So we need to understand that opportunity. We need to understand what's available to it. So what are some examples of challenges that the learning engineering process may allow us to address across MIT? Let's look at some example challenges. So one example challenge is, imagine you have a Lightboard studio and you need to help instructors be ready to use that effectively. That seems like a pretty important challenge for addressing learner needs. The learners in this case being instructors. We want to develop instructor capacity to enter the studio, be ready to sort of do effective captures from day one. We want them to be able to use the equipment easily, be able to see how to set it up, and then end-to-end workflow. We want them to be able to do that from step one to the end, walk away with their video that they can use for their class the way they want. That's the goal, right? So imagine if that was a challenge that you needed to address. How might you think about trying to address that challenge? We talk more about it in this citation, just so you know. But that's one example of a challenge. Another example of a challenge comes from physics, Electrostatics Playground Challenge. Their challenge was, how do we get students to collaboratively engage with electrostatics representations? Electrostatics is a notorious difficult concept for introductory physics. There's not a lot of great representations and models out there in the traditional forms. And so how do we get students to collaboratively engage in this VR system that allows them to sort of gain some deep understanding of those basic principles of physics? That seems like a pretty reasonable challenge to put in the center of that piece. Again, we talk about it, so there's some citations for everyone along the way. So I guess this raises a question, right? These are just broad examples, but I want you to take a minute yourself and think about what challenge might you want to center in the learning engineering process? What is something that you care deeply about to put in the middle of this? Maybe it's with your learners in a class. Or maybe the challenge is a little bit bigger than that. Maybe, for example, your challenge is across courses or across a set of courses. Maybe across a department or multiple departments. So just give you a second, think about a challenge that you would want to put in the center of this process. there might be multiple types of challenges, right? So if you've got one level of challenge that is associated with just fundamental use, factual retrieval of like how to do X in the system, right? Versus then a second level, which is how do I use X to teach a class, right? So you've got multiple challenges happening that you've got to sort of center. And we'll talk about learners here in a minute because I'm glad you foreshadowed that a little bit. So once we have a central challenge, whatever that challenge might be, whatever your focus is that you want to address with your students, it's contextualized. So what does that mean? Well, it means that within that challenge, or that challenge is situated within a context of resources, the available platforms that the students might use, whether that be Lightboard Studio, MITx, Canvas, VR system, right? For example, not everyone has access to a VR system, so maybe that's not the place to start in terms of thinking of solutions, right? It also has to do with constraints of timing. What are the timing resources for my learners and for me as an instructor, right? What can I bring to try to solve this problem? The type of course it is. Is it a full semester and I'm trying to solve a problem that bridges that whole semester? Is it a one course, one term piece that I've got very limited time to address? And then of course there's always that fun little thing called a budget, right? So the challenges associated with sort of the finances behind doing some of this work. Then we also have the learners, and this is sort of also part of this circle, right? So some examples of potential learners we may be thinking about. Instructors, we talked about that one at the front. Students, we talked about that one. But then there's also staff. Staff can be learners. TAs can be learners. There's a global audience. Maybe there's people who have already finished degrees. They're professionals out there in the world practicing whatever they're doing, and they're trying to learn new skills, new pieces. So there's lots of different learners. So what I want you to do is, like, as you thought about that challenge that you were trying to address, I want you to think very carefully about who are those learners for you, and back to what we talked about at the beginning, what do we actually know about them? What do we understand about where they are at in their trajectory of learning around this central challenge that I care about? All right. So then the last piece of that sort of way outer circle is a team. It takes a team oftentimes to do this work, right? In our context, as I mentioned earlier, residential education, we talk about teams that include learning sciences, learning design, ed tech, digital and data sciences, and learning analytics. These are pieces of our team that we bring together to try to solve these challenges. But that might not be the team that you have to solve your challenge, right? So think about, in your context, in your setting, who might be some of the people that can help with this work. Because this talk is mostly focused on MIT and our work here, I want to take a moment to sort of talk about, this is out of the Learning Engineering Toolkit, and it's meant to represent what the team is, right? So you've got learners, everything goes through the learners, they're in the first position. We've got some shared understanding in the middle, and then in the Learning Engineering Toolkit, we talk about a bunch of different people who may be brought together to try to solve that challenge, right? Not dissimilar to this image, there's this image of our team. So we've got Cheryl in the middle. Unfortunately, it's the only one I had. Sorry, Cheryl. And we've got our team around it. Now, it's not a one-to-one match of that flower you saw before. Our team's a little bit different, right? We bring expertise in online tools, in learning science, data analytics, and learning engineering, in outreach and amplification of quality practices, getting the word out about what digital innovation looks like. And then we've got the physical tools. We've got the people who are sort of experts in bringing things like Lightboard Studio and lecture capture to the community, right? So our team is made up of parts of that flower, right? And we do this work collaboratively. However, what you don't see up here, which I think is important, is subject matter expertise, right? This is where we as a team work with others in our community, mainly faculty and instructors and course teams, to engage in this work. They, as subject matter experts, are sort of the ones who are in the first position to come and work, and we work with them to make this process work, right? So this is our team. That's how we bring it together. which then allows us to sort of start to work on that outer level. I'm going to turn it over to my colleague Lauren, and she's going to give some examples of what it means to do the rest of this work.
So Aaron talked about learning engineering challenges, about teams. So one place that these teams can start addressing a challenge is in the creation part of the learning engineering process. So this part of the process basically consists of several mini and iterative cycles of designing, developing, instrumenting, and user testing of potential solutions. So we're going to talk through what creation could look like by discussing an example of work that our residential education team has been working on recently, which was a training for teaching assistants here at MIT. And so we're going to talk about this in sort of a timeline fashion. So last spring, we identified the opportunity to develop a training or a host of resources for TAs at MIT where the focus would be to prepare them to use Canvas and other related tools as part of their TA responsibilities. And we were planning to launch this in August 2022 so that TAs would have time to engage with those resources before starting their work in the fall semester. So we started to conduct some preliminary research to answer design questions that we had. For example, like what are the gaps in preparation for TAs learning how to use tools and being well equipped to manage things like a Canvas site as part of their responsibilities. And a big part of this research included human-centered approaches, which is a big part of learning engineering. An example of this was interviewing people from the biology department here about their department's own TA training. They happen to already have their own training and with a specific focus on pedagogy training as well. And so there was a lot to learn from them from their point of view as people who support TAs. So that was a really helpful influence into the design of our TA training that focused on technology. And so as we're getting these influences and these different sources and channels of inspiration to our design, we start to build. We're building this training on a Canvas site. And we're not just making design decisions, but we're tracking them too. And that's an important part of our own team's practice that I'll touch on more a little bit later. And then another part of our research too was collecting survey data and coding that data as a team from a survey that went out in the spring to faculty and to TAs specifically as well, where it asked them about their interactions with Canvas, their experiences using Canvas. And because the survey had TA-specific questions, that allowed us to see the point of view of TAs themselves and understand how they interact with Canvas and the tools that would be the content that we're talking about in the training that we're developing. So as we get later on in the summer, we start to finalize the build of the training itself in Canvas. Again, incorporating all of these influences that are coming from what we know about the context, what we know about the learners, the research that we've been doing, these human-centered approaches to collecting information about our learners, the TAs. And then in July, so right before we rolled out the training to our actual learner population, the TAs, we did some preliminary testing amongst our residential team. We also included some folks from IS&T in the Digital Learning Lab to user test this training in Canvas. And so what we did is we collected that feedback, we tracked it, we incorporated what we could that was immediately implementable, but we also flagged some feedback that might be useful later for a future iteration, which I'll talk about next. And so you can see from this timeline, you can get a sense of how what we were doing to build this training was like a mini cycle of creation and testing and investigation within the creation phase of the larger learning engineering process. And so as promised, I said I'd say a little bit more about what we mean by tracking our decisions and keeping record of all of those influences to our design. So a learning engineering practice that our team happens to use is something that we call design decision tracking. It really is as simple as just keeping an Excel worksheet. And so design decision tracking is a practice that helps teams make pedagogically sound and contextually sound design decisions. So you can see in the far right column where it says justification, that's where we note down the reason for why we made a certain design choice. And those are noted on the far left column. So we're really taking a minute to reflect on why we're making this decision, making sure that it is based on the learning sciences, based on what we know about how people learn, based on a whole host of other influences that I've already touched on. The tracker also serves as a communication tool as well. So I want to point out the middle column, which says influence/source. So these are just really brief, biteable ways to communicate to stakeholders, to other members of the team who are involved in this work, where a certain decision was coming from. Maybe, I mentioned that our team did some user testing. Maybe a tester pointed out some sort of feature in the training and they had a question about it. I would be able to go back to our tracker and quickly point out, oh, it functions this way because we made, XYZ decision and here's the reason for it. And the tracker also facilitates iteration and improvement. And we're currently in that stage right now in terms of the TA training. But basically what that means is we're going to go back to this tracker and look at this decision column and use some of these decisions as entry points to the next round of iteration and improvement of the training. So that's a bit about creation. Then we sort of move along in the cycle about implementation. So this is about implementing that design solution to the solution to the challenge, but with the real learners in their real context. And there's a lot to think about here in terms of implementation context, because it can mean different things for different people and different teams doing this work. So thinking back to the challenge that you thought of, your learners that you thought of earlier, what does implementation look like for you? So I'll give you a second to think about if you were to come up with a solution to the challenge that you were thinking about earlier, what might you consider about your implementation context that would be important to know? So, for example, maybe your context is at the classroom or lab level. Maybe it's department-wide. You might be thinking about, is this for a single cohort, multiple cohorts of students or learners, or is it on the scale of something like a global MOOC? So you can see that all these examples, maybe the examples that you're thinking of, really are very different. Their implementation context would be very different. So I'm going to dive a little bit deeper into implementation by bringing up some examples from consultations with faculty and course teams that our team is engaged with, just to really hit home the point that when you're working with teams and instructors on coming up with a solution and designing something for them to implement in their teaching practices, it's not just about designing, it's also about acknowledging the context that this design is going to be situated in and the whole host of factors that are associated with that. So you're designing, but you're also planning how that's going to be implemented. So one example is our team working with UPOP here at MIT to design their Canvas sites for their year-long program. So that alone, knowing that it's a whole year-long program for hundreds of students, is an important contextual factor to take into consideration. So we considered that when we were planning to design these Canvas sites. The course team was also new to Canvas, so also trying to factor in how it would be easy for this team to manage a Canvas site and all of their students. And then just knowing that the nature of the program involves a lot of events like workshops, and that instead of traditional grading that we might see in another type of course, this was really attendance-based grading. So considering things within Canvas we could use to make that happen. So what did we implement? We worked together, me and the student program coordinators from UPOP co-designed their fall 2022 Canvas site. And we strategically incorporated Canvas features and other LTIs that would account for these contextual factors of their implementation context that we talked about. And then another example is a little more generally, just helping an instructor choose a tool for grading and feedback. So this is going back instead of sort of the program level, this is on an individual class level. So the factors we considered here is that it's a medium-sized class, roughly. There are multiple graders who are involved in grading P-sets that students submit on a weekly basis. And there is a need for this tool to be integrated with the Canvas gradebook. So they already had a Canvas site that they were using this semester, already using gradebook, wanted it to be easily integrated with that. And so our solution was that we enabled the Gradescope LTI in Canvas on the site, and we created Gradescope assignments for those P-sets. So this was also in response to student feedback. So that's another important sort of contextual factor here is having feedback from students during the design process. They indicated that they would like to use Gradescope, and so that was also a main driver behind this decision as well. So just to note, these are current and ongoing consultations, and what we're going to work towards next is collecting evidence from the implementation to see if it's working. So we considered all we thought we could consider, we factored in everything, but we want to see if it's actually working in real life with the real learners. And so we'll be working on collecting that evidence next and seeing what we can do with that evidence to improve for the next time, for the next iteration. So for UPOP, it would be for their IAP and Spring Canvas sites. For this instructor, it would be to see if, did Gradescope work out the way that the course team and students hoped for.
So that's actually like the perfect transition, right? Because it's this question of, okay, you've implemented with data collection, now you've got to do something with that, right? So Lauren sort of led us to that point of like, hey, we're implementing this. This is running. These are current consultations. And now we need to think about what it means to investigate, right? And so you've got to complete the analysis. You have to identify ways to continuously improve. So the opportunities here are maybe go back into, I solved my challenge, hooray, I'm done, on to the next challenge. Or maybe it's my problem's not solved and I need to rethink my design, right? But you can't answer that question until you understand the input, the data, right? So as you think about your own challenge, the Challenge U Center, another way to think about it is like, what questions would you want to investigate about implementing the solution? So I'll give you an actual example. We did some work with 813 with his junior physics lab, right? So for a number of cycles several years ago, they were engaged in a curriculum improvement project. And at the core of that, Sean Robinson, who runs the lab, sort of forwarded this idea, right? Like, my goal is we need to improve students' pre-lab preparedness. Like, they're coming to lab, they need to be ready. We need to improve that. And I want to limit the required work outside of course. Right? Those were the two goals. And in the chapter, you can go read if you want, we talk all about what it meant to implement that. Short answer is, built a bunch of questions, pre-lab type questions that were auto-graded through the residential MITx system, implemented those with the students at various points leading up to when they would be coming to lab. And that was the idea, right? We're sort of replacing some of the pre-lab reading and the pre-lab writing into this system that they're engaged with, that they get feedback with right away, that the instructor can use. That's the core of the implementation. Go read it. It's a lot of fun. What I'm going to talk about is once it was implemented, though. So we actually collected data, right? And so the question is, well, there's two pieces here, actually, right? There's two goals that he really cared about. The first one is, like, are they ready for pre-lab? Like, did they come to lab ready? And there's sort of the anecdotal evidence of, like, the instructors all said, hey, the students actually came to class prepared, but that's not, like, reliable necessarily. It's valuable, but it's not necessarily reliable. So let's check it. How can we check it? Well, we can check it with platform data. I'm not going to get into all of this. Again, it's all in the chapter, but I wanted to point out, basically the idea was we were able to figure out, set a time before they were, this is when the class starts. So did their initial submission come in before class? And the answer was, across term after they started the implementation, almost 90% of students, above 90% of students for the most part, were submitting their initial response before class, which is amazing. So that paired with some other data, sort of triangulated, said, yep, we did part one, right? And then the second part was sort of like, okay, now what did this do to their work time out of class? Because that was a major concern, right? And so it just so happens part of this evaluation for the course is about student sort of saying, this is how much time I spent in and out of class. And this is where the implementation happened, right? So we sort of see everything before. Those are bigger. And after, those are less. In the chapter, we talk about how we actually analyze this data so that we could reliably know, yeah, in fact, this is less. The time they were spending in and out of class actually decreased. In class, decreased just a little bit, but out of class, decreased a lot. So we talk about how we analyze that there. My larger point is to come back to this piece, which was what that allowed Sean to do is allowed him to focus on other pieces of the implementation. It allowed him to sort of check off the boxes of like, yep, I addressed those central challenges, and now I'm on to trying to address the next set of things that I care deeply about. What's the next part of the work in this curriculum redevelopment that I can engage in? So for him, it was a whole new cycle. It was a whole new challenge. For others, maybe, for example, we get that data back and it turns out students were spending a ton more time outside of class. Well, then that wouldn't work. And we would need to really rethink how we were maybe implementing it or what we had actually designed. But it gives us insight and lens into the iteration of these materials, these resources, and the implementation. So for today's conversation, we started with creation. Like that's where we started in the talk. But that's not actually where you need to start, right? It's entirely possible you already have something that you're working with. You already have a course you teach, you already have materials, you already have pieces. And maybe you actually want to start over here with investigation. Like you've got platform data and you want to start with asking a question, looking at the data, and then jumping into the cycles, right? Or maybe I want to start with just defining my challenge altogether. Like I'm starting from scratch. Maybe it's a whole new course. We see that. It's a whole new course. I'm starting from scratch. What is the thing I care deeply about for my students to know when they're done with the course or with the program? So I'll leave with this one piece here. So there's also different levels. We've sort of alluded to it a couple of times. There's sort of this level of like classes and then departments, maybe schools, and then across the institute. And then there's this whole external audience, right? We've referenced MOOCs a fair bit, but it can be any external audience, right? So maybe it is high school learners who come to campus in the summer. Maybe it's students who have been admitted to MIT who we want to engage with before they get here for their first term. Maybe it's graduates who are leaving and we want to support as they go on to their next step. Could be any number of things that fit into this. But what I want to pose to those in the room and the community who's hopefully watching this at some point in the future is I challenge you to fill in these pieces. I want you to really think hard about like, where are there examples of this happening already? Maybe you don't call it learning engineering, but you're like, oh yeah, we're doing parts of that. Maybe not all of it, but we're doing like, oh yeah, we started talking about this and that would fit here or here. And then I challenge you to sort of think really hard about what could it be? What do you want it to be? And how might our team come together to help you achieve some of those pieces? So I sort of open it up to questions and discussion to those that want to do that. I'll circle back to this discussion slide in a second, but just to say, if you're interested in learning more about sharing your own pieces or amplifying your work, consultations or just conversations, please reach out, ol-residential@mit.edu. Exploring existing materials, we've got a number of great pieces on residential digital innovations, past xTalks and the Festival of Learning, and then our Canvas resource site for instructors has a lot of great resources and connections to almost all of those pieces as well. And then I'll leave one last piece. Learning engineering is work that we do in our group, but it's not work that is exclusive to MIT. And so I would be remiss if I didn't call out the community for IEEE iSchool, who is mostly behind the Learning Engineering Toolkit book. Thank you.